In this video, we are going to discuss about Venn diagram. So Venn diagram is basically the graphical method of representing set, or it graphically shows relationship between sets. So this is the main use of the Venn diagram. Okay, so let's see that how do we do it. Here the strategy is that different sets, they are represented by using circle. Okay, so for example, this is set A. So set A will be represented graphically by using circle, and the elements of A would be there in it. For example, if A is a set of first three natural numbers, so all those three natural numbers would go inside it. So it is set A, right? Okay, now one very important thing, that all the sets that we consider are basically in universal set. So we always draw universal set around it. Okay, so this is how we draw the Venn diagram. So this was the Venn diagram when we have one set A. But if we have two sets, okay, if we have two sets, then again we draw universal set, and within the universal set we have different sets, and there could be a different kind of relationship between sets. So let's suppose this is set A, this is set B, and there could be different kind of relationship that can be shown. We are going to discuss it in the detail. So the first thing that you have got from here is that we use circles to represent sets. The second thing is we always put the circles in universal set, right? So this is the basic thing about the Venn diagram. Now let's see different relationships that set can have, and we represent it graphically using Venn diagram. Let's explore different relationship between two sets by using Venn diagram. So the first one would be superset subset relationship. The second would be the overlapping, and the third would be disjoint. So let's see that how do we represent these three relationships by using Venn diagram. So let's suppose relationship which is the superset subset relationship by using Venn diagram. So here you can see that A is equals to 1 2 3 4 5 6, which is the set of first six natural numbers, and the second set is 2 4 6, which is basically the subset, and it is taken from this set. Okay, this is the subset of it. So how to represent it using Venn diagram? Now here you can see all the elements are there in it. So this is the superset, and this is the subset. So here the superset can be drawn with the by using circle. Okay, so this is A. The subset, since it's a set which contains all the elements, so it goes inside, right? This is E. Here we have, in E we have 2 4 6. In A we are left with 1 3 5. Alright, so this Venn diagram shows the superset subset relationship. So you can always put this inside the universal set. So this is the universal set. So this is how we represent this subset superset relationship by using Venn diagram. So this shows the relationship that E is basically contained in A, or it is the subset of A. Now let's see the second relationship, which is the overlapping. Now in overlapping set, there are few elements which are common, rest of the others are uncommon. So here let's first figure out the common elements. We have 2, 4, 6 common, other all are uncommon. So let's draw this. Let's first draw A. So this is A. Now let's draw B. So here goes B. Now why I have made it this way? Because there would be few elements which would be in both of them. 2, 6, 2, 6, 4, these are in both of them. So we are going to write the common elements or the shared elements here, so that in this part, so that they represent both the sets. So let's write it. 2, 4, 6. In A we have 1, 3, 5 uncommon. 1, 3, 5. And here we have 8 only. So here we go. Not least, we always put this in universal set. So here is our universal set. So this shows the overlapping relationship, or the relationship in which some elements are shared. So this is the shared or overlapped part. Okay, the last relationship is a disjoint sets, where there is no element common in both the sets. So here we can see that A is basically showing the even numbers, and B is showing the odd numbers. So even and odd, they are entirely different, they don't have anything in common. So let's try to draw it. Okay, so let's start with the universal set. So here we are is our universal set. Then let's make A 2, 4, 6, 8, B 1, 3, 5, 7. It's showing the relationship that they don't have anything in common. Okay, so this is how Venn diagrams are used to show whether the relationship is a superset, overlapping, or disjoint. So here we are going to see the Venn diagram in case of operations on sets. So there are, as you know, there are 4 operations: the union, intersection, difference operation, and the complement. So these are the very important operations, and the Venn diagram in each case is very important. Each can be divided into 3. The first one is subset, superset, subset. The second is overlapping, as we have read before. And the third is disjoint. So the union, when one is the subset and the other is superset. Union when two sets are overlapping. Union when they are disjoint. Same goes with the intersection. So subset, superset, overlapping, intersection when disjoint. So in each case there are further 3 possibilities. If you have any problem in any of the operations, you can watch my videos on it. There are dedicated videos on union, intersection, difference, complement, which would be very helpful for you to understand, because it contains various examples along with the Venn diagram. So let's just briefly discuss that in each case how we are going to draw the Venn diagram. Okay, so now let's see the first operation, which is the union one, and we have got 3 cases as we have discussed. There is first case is the sub super case, the second is the overlapping, and disjoint. So these are the 3 conditions basically in which union operation you can be confronted with the union operation. Okay, so let's first start off with this one, the sub super, in which one is the subset and the other is the superset. So here this is the subset and this is the superset. Okay, because all the elements of A are in B, so therefore it is the subset, smaller set, or the set which is taken out from B, right? Now, union operation is basically joining both of them, or union operation consists of all the elements in both, common or uncommon. So A union B is, I'm doing here directly because I'm supposing that you know all, and we are here to draw the Venn diagram basically. 1, 2, 3, 4, 5. So it has got all the elements in A and B. Now let's draw the Venn diagram in this case. Okay, so in this case we first draw the superset because superset is a bigger set. So here is our superset, which is B, and since A is a subset, it is the baby set, you can say, so it goes inside it. So this is A. Now A has elements 1, 2, and B has elements 1 and 2, they are common, so we have written ones here in A. We are left with 3, 4, 5. So 3, 4, 5. Now in union operation, since if you can see here in this tabular form all the elements are included, so to graphically represent that it contains all the elements, we color everything. So this is how we show the union of subset superset. Okay, so our answer includes basically pretty much everything which is in both, right? So we are going to color everything so it shows the union. Now let's see the second one, which is the overlapping. In overlapping there are some elements which common. So here you can see 3 as common. Rest of the other elements are not common. So there has to be some common elements and some uncommon in overlapping sets. C union D equals to, I'm doing it directly here as well, so it contains 1, 2, 3. Since 3 is in both, so we are going to write only once, 3, 4, 5. So here goes our overlapping, the union of overlapping. Now how we are going to draw the Venn diagram? Now in this case we cannot draw this one because this is a subset, right? Since in this case some of the elements are common, rest of the others are not. So let's suppose this is C and let's suppose this is D. Okay, let's first write the common elements. So here we have 3 common. So 3 would go here because it is common, right, in both of them. So this is the part of D as well, and it is a part of C as well. So 3. In C, we are left with 1 and 2. So 1, 2. And on the side of D, we are left with 4, 5. In order to show yes there's a union operation, we are going to shade everything common, uncommon, because our resultant set includes every element, so we are going to shade the entire diagram. So remember that in union we are going to shade everything. So now the last is the disjoint sets. Here we have E equals to A, B, C, F equals to D, E, F. Now since it's disjoint, that means no element is common. Okay, so in this case E union F is going to be A, B, C, D, E, F. We are going to write all the elements common, uncommon. So let's draw the Venn diagram. Since we don't have anything in common, so we are going to make separate circles for E and F. So this is the circle of E, this is the circle of F. In E we have A, B, C. In F we are having D, E, F. Right? Now since it's a union operation, okay, union operation of disjoint sets, we are going to color it because our answer in the tabular form contains everything. So this shading shows that this is the union operation. If everything is shaded, it shows the union, right? I hope that you have understood the union operation, and for detailed videos you can watch the dedicated video on the union operation. Okay, now we are now going to discuss the second operation, which is the intersection operation. And in this case as well, we are having three cases: the subset superset relationship, overlapping, and disjoint. Let's first see the sub and super. Now, since it's intersection, so we are going to only consider the elements which are common in both of them, right? Let's see that how we can do it graphically. So I'm doing it uh, for in tabular form as well to make you understand. So here we are going to see what's common. So here 3 is common, okay, and 4 is common. So 3, 4. Now graphically, as I said, in sub and super, we first draw the bigger set, which is a superset. So this is the superset B. You can make use of the compass or some circular thing for it. I'm just drawing it roughly. So B, and the smaller set goes inside, which is A. So this is A. So we have 3 and 4, right? And inside of B we are having 1 and 2 only. So 1, 2. Now since it's intersection only covers the common elements, so here we are going to highlight only the elements which are common. Here we are not going to shade everything, that is the union, okay? In intersection we are just going to shade the common part. So here 3 and 4 is the common. Let's move on to the second one, which is the overlapping. So here we have C equals to ABC, D equals to BCD. Now C intersection D is equals to, here we have B and C common. So B and C are going to be common, and rest of the others, which includes A and D, they are uncommon. So this is the overlapping relationship. Let's draw the Venn diagram. So in overlapping, as I said, we have some elements common. So we have to provide the provision for the common elements and for the uncommon elements. This is C and this is D, right? So in here we have there are two elements which are common, right? So let's write the common elements first. So we have B and C common, B and C common, and the uncommon are A on the side of C, and on the D we have D. Now since it's intersection, we are not going to color everything, we are just going to color the common part. So this shows the intersection in case of overlapping. The third case is a disjoint case, right? And disjoint in the intersection. So E intersection F, so there's nothing which is common, right? So it's going to be the null set. How are you going to make the Venn diagram in this case then? Let's say this is E, and E has elements 1, 2, and this is F. It has got elements 3, 4, 5, 6. And since there is nothing common, we are not going to color anything in it. So this is the intersection of disjoint set. It graphically shows that there is nothing common in both of them. Here it shows graphically there is only B and C which are common, and here only 3 and 4 common. So I hope that you have understood the intersection, the Venn diagrams, how to draw the Venn diagram in each case of intersection. Okay, so now the third operation, which is the difference operation. So let's see in each case. The first one is the subset superset, of course. Here B is the subset, this is the subset, and this is the superset, right? So how are we going to do the difference A minus B? So as you know that in this we omit the common ones and we are only left with the element which is left in the first one. So here if you see we have 2 in both, so we omitted 4 in both, so we are left with 6, right? So 6. How we are going to show this in Venn diagram? So this is set A, and in set A we have a small set B. B has 2 4 which is common to both, and in A we have 6. So since this is the difference operation, so our, if you can see here, so A minus B, it gives us 6. So difference operation. So difference deals with what is left in the first one. We are only concerned with what is left in first one. So here 6 is left. So we are just going to shade this 6 or the outer of this, outer side of the B. So this is the A minus B. Let's move on to the overlapping where we have to do C minus D. Okay, so in C minus D we have 3 in both, so we omit 4, we omit. So in the first one, that is in C, we are only left with 1 and 2. As I said, in difference we are only concerned in what is left in the first one. So 1 2. Let's draw the Venn diagram. So we have C, this is C, this is D. So here we have common elements 3 and 4. At the side of C we have 1 2, and here we have 5. Since we are doing C minus D, we are only concerned with what is in C. We are just going to color C in this case. So this shows C minus D. If it is D minus C, then we will only color D, because we would be interested in what is left in D, right? Since D is the first one. Okay, so you can watch my difference video if you want to know in detail. Right now we are just going to see how we can draw the Venn diagram in each case, right? Now in this case we have E minus F. That means we are just interested in what is in E. So since there is nothing common, so we are not going to omit anything. Since E is first, so we are going to have the set only belonging to the elements in E. Okay, so let's draw the Venn diagram. Here we have E, which is A, B, C. Here we are having F, which is P, Q, R. Since we are doing the difference, so we are just going to color E because this is our answer. Okay, the fourth one is the complement operation. So the complement operation is just like the difference operation. The only difference is that in difference operation we subtract from any given set, for example A minus B. But here in complement we always subtract from the universal set, that is U minus A. So here let's do it directly. Let's see the common elements and omit them. We have 2 common, 4 and 6. So in the first one, or in the universal set, we are only left with 1 3 5. So here our answer for A complement, that is the set consists of all those elements which are not in A. So it is 1 3 5. Now let's draw the Venn diagram. So as we have discussed that the universal set always goes in the rectangle. So here is our rectangle, which is for the universal set, and the A goes inside it. So A has got element 2 4 6, and here in the universal set we have 1 3, 5. Since we are doing u minus a and our answer is everything except a, so everything except a is outside the a. So here this shows a complement. So everything apart from a is colored, that is everything outside a is colored. So this shows the A complement. I hope that you found this video useful. Have a happy learning. Don't forget to like, share and subscribe to my channel.